This is Terry and I'm going to give my feasibility study for ISDN 2603. For the introduction to IGL, they focus on 3 parts. The first one will be the sustainable energy. It is a solar energy system that can be integrated into buildings for sustainable energy management. And the Agile lens is a new way to concentrate the solar energy without the tracking systems. In this study, I'm going to focus on the material. This study investigating the feasibility of the Agile lenses made from glass and plastics for building applications. We are going to comparing the glass and the polymers. In general, glass has a high optical clarity, excellent scratch resistance, stable refractive index, and superior thermal stability, while polymers are lightweight, cost-efficient, and versatile modeling capabilities with a higher impact resistance. Now for the experimental methodology, I'm going to approach my result in 3 ways. The first one will be the optical performance, the second one will be mechanical properties, and the third one will be the durability test. For the optical performance result, we can see that in general, glass have a slightly less refractive index than polymer. However, the polymer's Ri is ingraded while glass has a uniform one. The transmit efficiency in glass is higher than the polymer, while the concentration ratio is much higher than the polymer. The mechanical property result, the glass will have a tensile strength of 50, elastic modulus have a 70, and the impact resistance will be 2 joules per meter square, while the polymer have a tensile strength of 35 megapa, elastic modulus with 3, and impact resistance of 15. This is the stress strain curves for glass and polymer lenses. In this, we will give a conclusion that for the durability test results, there will be after 100 hours EV exposure, no significant degradation about observed for glass. However, there will be 15% of polymer degradation after the 1000-hour UV exposure. And there will be 10 to 20% of scratch resistance for the surface roughness for polymer compared to the glass. And then under the 300 thermal cycles, the exhibition slightly wrapping and micro cracking effect on the polymer integrative, while the glass don't have these kind of results. Now analyze for the experimental data. For the optical performance, glass is better than polymer in transmission efficiency and concentration ratio because it has a stable and higher refractive index. But polymers still achieve good concentration ratio and can be improved, making them a good alternatives. The mechanical property, the glass will be more rigid and has a better structural stability. However, it is brittle and has a low impact resistance, which are major drawbacks. Polymer will have a higher tensile strength and a better impact resistance. They can handle mechanical stress better, making them suitable for changing environmental conditions. For the durability, the glass is very durable against the UV light exposure and resistant to scratches, which is important for long-term outdoor use. The polymers are less durable in these areas, but they can be enhanced with protective coating and material change. Thermal stability, the glass maintains its optical and structural integrity during their thermal cycling. On the other hand, polymer can deform and develop micro cracks, which may reduce their functionality over time. The glass function properties. The glass will have a high optical clarity and then with a stable refractive index, and in the scratch resistance it will be better comparing to the polymers and a better thermal stability as well. For the polymer, it will have a lightweight nature depending on the structure, and the facility is easier for them to install on the outside, and also the flexibility with the better cost effectiveness, and then for the impact resistance. The atomic structure crystal and their changes under stimuli. For the glass, the atomic structure has a disordered network, giving it the same optical property in all directions. This helps bend light uniformly for edge to work well. Behavior under stimuli keeps its structure under heat and mechanical stress, but can break easily and crack with sudden temperature changes because it lacks of defects that absorb stress. For polymer, the atomic structure can be semi-crystalline or amorphous based on their types. The semi-crystalline parts make it stronger, while the amorphous parts make it more flexible. The behavior under the stimuli, they can be bent when stressed thanks to the molecular movements. UV light can break the molecular chains, weaken its mechanical and optical properties. The relationship between material properties and behavior under loads. As for the glass, it has a high elastic modulus and tensile strength, make it rigid and resistant to shape changes under the comparison, keeping the IGL lenses stable. And the brittleness make it hard to absorb impact energy, causing it to fall suddenly under stress or impact. The polymer will have a low elastic modular but higher tensile strength, balance flexing and strength, helping it handle dynamic loads without breaking. The ductility and toughness allows the polymer to absorb and spread out energy from impacts or vibrations, making them last longer in changing environments. The failure modes under the stress. For the glass, it is brittle fracture. Starts with a tiny flaws or cracks leading to a quick and total breakage without much bending. For the thermal shock, the quick temperature changes create internal stress causing cracks or breaks. As for the polymers, the creep slowly bend under the constant loads, which can distort the agile lenses and affect how it works. The environmental stress cracking, mix of a mechanical stress and chemical like UV light speed up the crack formation of the polymers. And the fatigue of the polymers repeating loading cycle building up a tiny cracks eventually might cause the polymer to have a material fail. As for the application for the product design, we are hoping to have the glass lenses have a tempered and laminated glass for safety, strong mounting system for structure support, and the protective coating for durability. As for the polymer lenses, the UV stabilization to prevent degradation and the scratch-resistant coating for durability and flexing mounting options for temperature changes. In general, we hope to use a hybrid approach, probably combining the glass and polymers for optimal performance and developing advanced material for improved properties. Conclusion: the glass offers a superior optical performance and durability, making it ideal for the application require high light transmission and scratch resistance. The polymers is lightweight and impact resistant, but require improvements in UV stability and scratch resistance for outdoor use. So we hope to have a mixed approach, which has a glass outside of the eye gel, and then for the inner one that contact to the steel structure, those places requires for the impact resistance, we can use polymer to transition it with the best solution.